that time, and I think 5 is the time. Like we should know it. I mean, prior to our classes. That's a question.
I'm sorry, I'm hardly able to hear you. Please repeat that and try to hold your earphone close by.
I mean, what I was saying, I was requesting for you to tell us the schedule, like permanent schedule for the week, so that we may also be able to know like what is coming, because it was just yesterday that we knew the class is going to change from the time that we always have to new schedule.
So here's it will work out. I work in another place, and I have a busy schedule. I would say crazy schedule throughout the day. So typically the pattern that I would follow is every day I will be available to take a class at 5 CST or 6 CST most likely, but that might change, and please be flexible with my schedule, because just in case if I have a carried over meeting, or just in case if I have another interview call at that particular point of time, I may not be able to take the class, and I will be postponing it or preponing it by 1 hour. But 5 CST or 6 CST will most likely be the class timings, but always be flexible.
Thank you.
Any other questions? Cool, I'll take the silence as no questions. So here's what we'll do, okay? So as I've mentioned, I will be teaching you all cloud concepts and cloud. I mean, we'll get into depth of what cloud is and why do we have to learn cloud, and why is every company looking for DevOps and cloud experience, okay? But before taking a step ahead, we'll actually try to understand what you guys have done so far, what you guys have learned so far, because every day in the class, every day as a part of the group conversation, I would see Chenna has taught you all Linux classes and also a bit of Python classes and also introduction to Jenkins, right? So I'll quickly go over the class and ask everyone a question on what you all have learned over Linux and Python. Is that okay?
Okay.
Cool. Pavan.
Yes, Srinivas.
What flavors of Linux have you worked on so far, or what are the different flavors of Linux available?
Sure. The flavors available are Ubuntu, CentOS, Red Hat.
Okay, and which one have you worked on?
Red Hat.
Okay, Red Hat, you mean in your corporate environment or in your personal machine?
Corporate environment.
Cool, awesome. So how would you log into a Linux server?
Sorry?
How would you log into a Linux server? How would you log into a Linux server?
Sure. Yeah, I mean, through PuTTY or OpenSSH.
Okay, PuTTY is just a tool that will help you to log into a server, a Linux server. But what is the mechanism called as?
I mean, we can log in through command prompt, or we can, there are several using IP address of the server.
Exactly. What is that called as? Using IP address of the server. What is SSH? How would you log into a server? Is it using user ID and password? Yes or no?
Yes.
What for is that yes?
We log in with, a command prompt.
I understand command prompt is the terminal, or command prompt is the medium using which you will log into a Linux server. But what is the mechanism? Tell me the command that you will use to log into an EC2 or into a Linux server. Cool. I understand how much you have heard. Mahima. Can you hear me?
Yes.
Cool. Tell me what is the difference between systemd and initd? This is a question with respect to your Linux.
Srinivas, I joined actually last week, so I am yet ramping up. So if you give me this weekend, I will, yeah, I'll ramp up more.
What all classes have you attended so far? I'll ask you questions on basis of that.
Python, from Python onwards, I attended. So I'm
Okay.
yet, listening to the other recordings, and I'm still ramping up.
Cool. What is a list in Python? What is a dictionary in Python?
Dictionaries, the items which we save to access in the program, during program.
Dictionaries in which you will save items to access within the program. What is that answer called as? Is that a technical answer? And you mentioned you have gone through the Python classes, right?
Yes, that was first class I attended.
Cool. Radhika,
Yes.
have you attended Linux, Python, everything?
Yes.
What is the difference between systemd and initd?
So systemd and init, they come in the process of Linux booting process when the system starts to boot up. So systemd is available in the newer version of the Linux, and init is available in the older versions. So basically it initializes the kernel. Oh, sorry. Actually, grub does that. This is after the kernel has started. All the initial processes that are available in the system will be started by the init process.
What does it mean?
Starting.
It is considered as the first process within any Linux.
Yes.
Cool. What we call it as a parent process. Okay. Good answer.
Yes.
Awesome. So basically, your answer was 90% correct, but it was at one stage where you have that systemd applies for newer versions of Linux machine and initd applies for older versions. You have to mention a term. It is not older or newer. What do you mean by older or newer? You have to mention that systemd is being applied as the underlying parent process for RHEL 7. 7 is the version, RHEL 7 and later. initd has been the underlying parent process module for your RHEL 6 and lower module.
Okay.
Cool.
Okay. Thank you.
No problem. Nikhil.
Yes.
What is SSH?
Secure shell.
Not just the full form, dude. What do you do with SSH?
Actually, we jump the firewall in order to access a server.
Okay. What is the syntax? You have that syntax on top of your mind?
SSH -i username @IP address.
Cool. Awesome. Thank you. Gangadhar.
Yes.
What is a dictionary in Python?
Dictionary we use to store the string values.
What do you mean by distinct values?
Sorry, I did not get.
What is a dictionary in Python?
Dictionary we use to store the string values.
What is that?
To store the string values.
If I have to store string values, then what is a list used for?
I don't know. Actually.
Have you attended Python classes?
No. This is my first class.
Okay. Shireen.
Yes, Srinivas. Yes.
Cool. Tell me what is a list or what is a dictionary in Python?
I'll tell you. I'll tell about the list. It's a collection which is ordered and changeable, and it allows the duplicate members. So it's usually has the numbers in it. So, and what was the another question?
It's okay. I'll take it forward. Thank you.
Okay, thank you.
Cool, awesome, right? Today we have spent a bit of extra time in order to understand what you guys are up to. It seems like none of y'all, except one or two, none of y'all are up to speed in terms of what has been covered so far. I would recommend every one of y'all to go through the Linux recordings, Python recordings by this weekend. And from next Monday onwards, I would not just ask questions on what topics I cover, but also I would ask questions on the previously covered topics, which is, Linux, Python. I can pick any question from any domain. Okay. So just be ready for surprises. And here's what we'll learn as a part of cloud. Okay. Let me share my screen. First of all, let me close all the terminals here. Okay, cool. So I'm sharing my screen. You guys can see my screen, right?
Yes,
we can. No.
Yes.
Cool, awesome, right? So here's what you guys might have learned so far. Like you guys have learned Linux, you guys have learned Python, and a bit of introduction to Jenkins. And maybe you guys might have heard about the term DevOps or CI/CD in general, right? So why do we have to learn cloud, or why do we have to, why did you guys learn Linux? Okay. So here's what happens. Typically, whenever you get placed as a DevOps or a cloud engineer, most of your environments, which is most of your job related environments, will be a Linux based environments, which means most of your, I would say 80% of your workload will be on Linux basis, and 20% of your work might be on Windows based machines. So which is why we have picked Linux as the prerequisite for all of our classes. Okay. So which is why you guys have learned Linux. And then later on, why did you guys learn Python? That's the next question. So the reason you have learned Python is typically, for example, whenever you are hired as a DevOps or cloud engineer, right, you would have to not just build DevOps principles, not just build DevOps processes, but also in order to implement a DevOps process, you might have to automate, which means you might have to write code, be it in terms of Python or shell. Okay. If you are asked to write script, most of the preferred language for writing scripting is Python. Okay. Which is why you guys have learned Python. You guys have learned the basic terminology of what is list, what is tuple, what is dictionary. Why do I have to use those basic data types, and how do I have to write a Python script? So I hope all those concepts are covered. And that is the primary reason for which you have learned Python, in order to automate stuff. And what do you have to automate? That is something that we learn while we are learning cloud concepts. Okay. And then later on, after learning Python, what you guys have learned? You guys have learned what is Jenkins, what is the purpose of Jenkins, why do you use Jenkins, and so on and so forth. Okay. And then later on, here comes cloud, right? So before getting into cloud, what exactly cloud means and why do we have to learn cloud is an important question. Okay. So typically, right, back in decades, I mean, I would say, like back 20 to 30 years back, every company, like for example, Netflix.com, Amazon.com, or any company you name, Microsoft.com, right? Every company has been lying on-premise. What do you mean by on-premise, right? For example, let's take example of Microsoft.com. Okay. Microsoft.com infrastructure, which means Microsoft.com, the entire website or whatever services they offer. Previously, all those software applications have been deployed on top of physical servers, which means that particular company, Microsoft, has their own set of physical servers, and they have deployed their application or their web services on top of those physical servers. So this has been the pattern for last 20 to 30 years. And now what happens? Microsoft or Amazon or any company in general, right now, software talent has become obvious that every company, again, I'm saying, if you're not talking, you should be on mute. Okay. So every company is in the process of, hiring software rich talent, and they are not willing to invest more time, and they are not willing to invest more cycles around, maintaining the same data, their data center or on-premise infrastructure. What does it mean? For example, Microsoft, like for example, 10 years back, they might have had 300 softwares to manage. And for example, at this moment, they might have had 30,000 softwares to manage. When I mean 30,000 softwares, it is like, it could be a web service, it could be a software, it could be any kind of software they vend and provide it to us, okay? So now what happens when they have to manage 300 softwares, they might have to deploy it on top of, for example, 1,000 physical servers. Now imagine the scale. They have grown from 300 to 30,000 softwares. Now what needs to happen? Imagine the amount of data centers they have to, imagine the amount of space they have to hire for data center. Imagine the number of physical servers they have to create and purchase. Imagine the amount of IT personnel, network admins, system admins, database admins they have to hire in order to put the physical infrastructure in place in order to accommodate the incoming 30,000 new softwares. So this has been the pattern going on, and this has been the actual business problem, what you call it as, okay? So what needs to happen? For example, in future, right? Let's say 30,000 might be the count for by the month of July 2020. And all of a sudden, by Q3, Microsoft might release 20 new softwares, okay? They have the talent of releasing 20 new softwares within 1 quarter, but they, not just they, but everyone do not have any super talent in order to create infrastructure for those new 20 softwares. What does it mean? It means that even though they have that software rich talent in order to create that application or in order to program that application, creating new physical servers is not something that you can do within a single quarter, or you cannot do that within a month. What does it mean? Which means in order to create a physical server, there is a lot of process that you have to follow, which means you have to buy the bare metal infrastructure, what we call it as, the underlying infrastructure for your server, and then later on hire or, typically use the existing storage array. This is your physical server infrastructure. This is your SAN arrays, what we call it as storage array networks. You have to integrate your SAN arrays to your physical server. Then later on, you have to buy network cables, and then later on start racking the entire physical servers to different components. And then later on, you have to bring in an IT guy in order to start installing the host operating system. And then later on, you have to bring in a security guy to make sure that entire stuff has been installed and fixed properly. And then later on, that security guy would come and start performing different levels of security testing. It could be pen testing, it could be security testing, it could be any kind of proprietary testing which is recommended by that particular company. For example, Microsoft is one such company. For example, if I take an example of Chase, right? It's a banking company. Banking company has their own regulations and their own compliances, and that might need their security guy perform additional levels of testing. Okay, so this is how this is how the workflow is. Okay, and now here comes the complexity. Even though they were able to build an application, build 20 applications within a quarter, imagine the pain that you have to go through in order to just create one physical server. And now multiply this one physical server effort into the number of servers needed for these 20 applications, right? So this has been the complexity that every company has been bearing for years together until the concept of cloud came into existence. By the concept of cloud, what it means, now everyone is moving to cloud. Why? What problem does it solve? Is a bigger puzzle, right? By the concept of moving to cloud, what happens is typically everyone is started adopting cloud. Now, what are the possible cloud providers available in the market? You have AWS, which is provided by Amazon company. You have Azure provided by Microsoft company. You have GCP provided by Google. You have Oracle Cloud provided by Oracle company. And not just them, there are other low-lying vendors as well who offer cloud, but these are something that you have to remember on top of your mind. Okay. Again, something which is offered by Amazon is AWS, something which is offered by Microsoft is Azure, something which is offered by Google is called as GCP. Okay. Now, what cloud are we learning as a part of this? We will be learning AWS in depth. and most of the job requirements in the market will be asking for AWS. I mean, at least I would say 60 to 70% of your requirements will be asking for experience on AWS. But nowadays the pattern has been changing, where you'll start seeing good amount of requirements on Azure and good amount of requirements on GCP. So the model that we have to adapt is we have to become pretty solid with one cloud provider. And then later on, based on your job requirement or based on the kind of job that you land in, you have to pick the other cloud on fly. Okay, so here is a point. With the level of cloud knowledge that we gain by learning AWS, it will be very easy to apply the same fundamentals to Azure or GCP. What it means is, for example, it is the same server knowledge, it is the same database knowledge, it is the same storage knowledge, it is the same networking knowledge that we will be learning in AWS, and it can be reapplied to other cloud providers. What it means is there are same set of resources available within every cloud. It's just that the naming difference and the name differs within every cloud provider. Okay, so that has been that is something that we would have to remember before moving into cloud provider. Okay, and then later on, any questions so far?
No.
No.
Cool. Pawan, why do we have to why should we learn cloud? Pawan, can you hear me?
Yeah. Yeah, to expand the services. It helps to identify the opportunities.
What does it mean?
I mean, it got a better insight. It helps collaboration.
Nikhil, why do we have to move to cloud?
Generally, actually, on-prem we have to maintain a lot of servers, which needs a lot of investment, and like people also need to be involved in order to maintain those things. So whereas cloud removes all those things involved, and which is maintained by the companies which are providing those cloud services, so which help decrease the investment in that, and also the pricing is accordingly cheaper, so that's why we are using cloud generally.
Cool, pretty good answer. You have pretty much covered the history of it as well, right?
Thank you.
So that is the reason, right? So pretty much, as I've mentioned, the reason for which I've given out this math is, right now, if I have to basically create infrastructure for this 20 new applications, imagine the pain that I have to go through. Now, by moving to cloud, what does it mean? If I'm moving from one thing to the other thing, what it means that the other thing is solving my purpose, right? In this scenario, cloud is solving my purpose. Now, what are the advantages you have by moving to cloud, right? Point number one, in cloud, you can imagine as if you are doing online shopping. What do you do by logging into Amazon.com? You just start picking your own set of shoes that you are interested in. You start picking your own apparel, and then later on push it to cart, and then later on purchase it, right? The same applies for every cloud provider. What happens is, for example, if Microsoft announces that it wants to, basically it wants infrastructure for these 20 new softwares or 20 new applications, what the employees of it would do, they would simply log into Azure portal, and then later on start picking services, which means if they want some Linux servers, they would simply order for Linux servers. For example, if they want 200 Linux servers, within next 2 minutes, they will simply order the 200 as a count. And within next 2 minutes, those 200 servers will be available. If they want, for example, 20 databases for those 20 applications, within next 5 to 10 minutes, they'll be having 20 databases up and running, readily available for them. So that is the kind of flexibility you will see when you start preferring a cloud model versus you maintaining your own on-premise infrastructure, which means within cloud, everything is pay as you go model, which means if you are willing to pay, then you'll get that service within next minute or two. And if you do not want that service, or if you no longer need that service, then you can immediately terminate that particular infrastructure, which means I can immediately terminate the database or Linux server or whatever resource that I've just created within that cloud environment. Okay. That's the reason they call it as, pay as you go model. And the other important advantage is, right now, if I have to maintain my own infrastructure, I would have to hire a bunch of folks and have to keep feeding them. One is IT admin, system admin, Linux or system admin, database admin, security admin, so on and so forth, or storage admin. Those are important folks. Okay. So by moving to cloud, what happens? You can literally get rid of all of these folks, which means you can lay off the entire team and just maintain one engineer or two engineers. And what are they called as? They are called as DevOps engineer. So we are the expertise, we are the talent that would basically shadow all these domains. And how are we able to cope up, and how are we able to catch up with all those concepts? It's because of the reason that as you're moving to cloud, most of the concepts or most of the backend management is being handled by the cloud itself, which means you as a DevOps engineer or you as an engineer, you are no longer looking into doing the backend management of those resources. Most of the aspects are already handled by cloud, and you as a DevOps engineer just need to handle the top level or the surface layer of that particular resource. So which is why we are able to oversee, or we are able to shadow most of the jobs that were done by those admins in the past. So that is advantage two. What is the other advantage? The other advantage is, for example, right, as every product or every resource in the industry has expiry. For example, let's say if you buy an iPhone, right, it would be able to, it functions normally for 2 to 3 years, and then later on, all of a sudden you'll start seeing slow behavior for whatever reasons, right? Same is the way every infrastructure in the market has a certain age, and after beyond one point, you'll start seeing that aging performance, which means you'll start seeing some degradation in its performance, right? So what happens, for example, after 20 years or 25 years, you would have to again go through the whole hassle of creating new infrastructure for 30,000 existing applications. Now imagine the pain. First of all, you have spent a lot of time on day one when you are creating infrastructure for this application, and you have to redo it after 25 years. Imagine that fact. Okay. Now coming to cloud, what happens? Yes, again, when you are moving to cloud, any cloud provider, AWS, Azure, or GCP, they are maintaining that physical infrastructure for you in the backend, which means even they have to do it on their end, but it's their headache, which means you as a customer or you are a client, you are no longer worrying about that backend management. What you are just worried about is, do I have access to AWS console or Azure console? Do I have 20 new servers up and running? Do I have 20 new databases up and running? That's all. That's all I need. That's all I care about, right? I am no longer worrying about the backend management. I am no longer worrying about the backend patch management, secure management, hypervisor level vulnerabilities, and top and other level stuff. Okay, so that is another advantage that you would have by moving to a cloud provider versus you maintain your own infrastructure.
I have a question. Can you repeat about that? We don't have to worry about it. What do you mean? When you say you don't have to worry
about maintaining the backend infrastructure, as cloud itself is managing it for you.
Thank you.
Cool. So I hope everything is clear.
Hi, Srinivas, Ahmed here.
What's up?
When we talk about backend infrastructure, so what are the key components? If you can throw some light on that.
What do you mean by key components? What I've been talking until now?
So the security, compliance, and all those things you are saying the backend only.
What are these big blocks that I've drawn here?
That's what I'm asking. Like, can you throw some more light on that?
No, I'm not understanding your question. First of all, I want to understand what you have understood from the explanation. You understood my point, right? It's very easy to ask, throw some more light, but what you want me to throw some light on? Pick that concept, pick that technical term that I'm wanting to listen. So basically what you have to do is, you have to, for example, if the box that I've drawn here is nothing but a physical server, right? As I've clearly mentioned, you would have to create your own physical server. You would have to bring in a storage guy in order to integrate a SAN array to your physical infrastructure layer. Then later on, you would have to bring in a network engineer to start integrating cabling, which means you have to basically make sure that this particular server has outbound connectivity, inbound connectivity, make sure that storage arrays and other arrays, for example, if I have to integrate some network file systems, then again, there needs to be some cabling in, right? So these are the kind of integrations that a company has to look into if they have to create one physical server. Now, by moving to cloud, you no longer need to worry about this big conversation. You would no longer need to worry about who manages what. You no longer need to worry about where is the storage engineer, where is the network engineer. You would no longer need to hire them at all. What needs to happen? You just need to hire a DevOps engineer who would be the guy who would be understanding what happens if I create a server on cloud, or how do I create a server on cloud, or how do I create a database on cloud. So we as a DevOps engineer, we need to know that how factor. Point number 2, we also need to know that this is something that we no longer need to manage. Even though we do not manage it, we need to have that understanding of we no longer need to manage it. Because typically when you're hired as a DevOps or cloud engineer, right, you'll be pulled into many meetings, and you'll be talking to many application architects, your existing data center infrastructure architects, and they'll be asking you continuously few questions. I mean, not everyone, but they might ask you. Or business teams who have zero technical knowledge, they might ask you questions around, hey, I heard that you are hired as a DevOps engineer. Why do I have to fund you? Or why do why is that every application moving to cloud? So these are the questions that you have to be ready about. And whenever you are asking someone a question, you have to be very specific, because you as a DevOps or a cloud engineer, you are the one who is throwing information. You are the one who is providing additional insight to everyone. So you cannot ask generic questions to someone and put them in confusion. So that is why when I'm expecting questions from you all, you have to be very specific about what you want me to talk about. And most of the time, you should be speaking the technical jargon. For example, if someone wants to ask me a question on, for example, hey, what is a SAN array? I want to hear that word SAN array, because it will not just help me in understanding, but it will also help you guys to pick that right technical term. And whenever you're talking in your interviews in the future time, you will no longer have that problem of using that generic jargon. And in the interviews, a guy like me would, within the first 6 seconds, I will understand if that guy has real experience or not. So start picking the technical jargon. I understand it will not happen within a day or two, but make that habit. Always try to use the technical term. If you have that problem, or if you are finding it hard to pick the right term, let me know. I'll help you pick the term. But I want you guys to use the right term when you are asking me a question.
Good. Thank you.
So let's move on. In the previous scenario, right, we have understood why do I have to move to cloud, and what can we expect from cloud. As I've mentioned, it is just like a shopping model. You just go log into a console or log into that AWS environment and start buying resources. And we'll see in reality what that looks like when we get to the AWS class point. Okay. So now, here is what happens. Typically, we have understood why would every company move to cloud. And then later on, there is something that we have to understand. Right now, every company is in a shape of using hybrid cloud model. So what is a hybrid cloud model? So in the previous discussion, I've mentioned that, the physical infrastructure has been moved to either AWS or either Azure or GCP, right? But what happens? What's happening nowadays, or maybe in the last 2 to 3 years, the pattern that we are seeing is the companies are preferring combination of clouds, which means previously they used to use just either AWS or Azure or GCP, but right now every company is using the combination of clouds, which means they are using AWS for compute capacity, which means for Linux workloads. They're using Azure for creating DevOps pipelines or DevOps processes. They're using GCP for running big data workloads. So you need not worry at this moment that if you have to learn all the 3 clouds. As I've mentioned again, I'll stick to my answer. You just have to learn one cloud provider in depth, and you can reapply the same concepts for the other cloud providers. Okay, so that's something that you have to understand. And then later on, okay, let's actually talk about. We have covered the history. We have covered about the shopping model and the advantages that a cloud provider has. And then later on, yep, let's actually touch a bit about DevOps, and then later on we'll pick other AWS resources. Okay. So I believe Chenna, the previous trainer, has covered DevOps for you guys. Is it true?
Yes.
Cool. So as a part of DevOps, what do you guys understand by the term DevOps? I want Abhishek, what do you mean by DevOps if you have attended the class?
Okay, so DevOps, I can say that it's a combination of different practices and tools to deliver application services.
Combination of different tools to deliver what?
Pardon?
To deliver what?
To deliver application services.
Application services. Can you elaborate it more? The answer is close, but it is generic. I cannot understand it. What do you mean by deliver?
Regarding the requirement, for example, if you are a client.
Okay, I'm the client. I gave you a requirement. Now what happens?
So when you're a client and you have given me a requirement, I will see what are the tools and tools required to deliver the results to you. So DevOps is a platform through which we collaborate using different tools and services so that we can deliver your solution at the earliest.
You can deliver me the solution at the earliest. I mean, the reason I'm extracting more information is your answer is close, but it is not accurate. It is generic again. So you have mentioned that if I am the client, I give you a requirement, you basically understand the requirement and you put all the DevOps principles or DevOps processes in place so that you can deliver a product very soon to me, right?
Yes.
Cool. So what are those principles or processes that you would put in place as a part of? Can you hear me?
Yeah, I can hear you.
Yeah, you mentioned that we'll use the right set of DevOps tools and right set of DevOps processes in order to deliver a product to the customer soon, right? What are those DevOps tools or what are DevOps processes?
Okay, I will say means there are, for example, planning stage, testing stage. You want me to define in terms of that or how?
I mean, it's up to you. I mean, I've asked you a question. Give me an answer, whatever sounds good to you, or
okay, so
relevant.
Okay, so when you get a requirement from client, you will plan, you will develop a code according to it, you will test the code, then you will release the code, then you will deploy. And when you are, for example, you are a client and I have delivered you the product. So after that, I will keep on monitoring regarding if the results are working for you or not. So the whole cycle will work according to that.
Where is DevOps in it? You mentioned that you will build the code, you will test it, you will you will test it, you'll promote it to environments, and then later on you'll ship the code, right? Where is DevOps in it? It's everything who is doing in it. Where is DevOps in it?
So DevOps is the whole process flow.
DevOps is the whole process. Okay.
Yeah.
Okay.
Which constitute everything.
As I've mentioned, you're close, but you're not 100% there. I'll let you know what I was expecting, okay? Because the point is, whenever you're explaining such questions in interviews, someone on the other end will be exactly looking for the right term or, the right terminology, okay? So what you meant is absolutely correct. As a client, I'll give you a requirement. You are the one who's an engineer, who is basically responsible to start programming it, then later on test, build, later on promote it to higher level environments and ship the code. But what is DevOps doing in it? It is every time you who is being referenced here. What DevOps does is a part of the pipeline. If you guys take a look at the screen here, for example, right, whenever a client gives a requirement, for example, for a feature, let's say, for example, if this is a feature to add a machine learning module to an application, right? There are, for example, 10 developers working on this particular feature in order to ship to the next sprint, okay? The next sprint is next Wednesday, for example, okay? Now what happens? 10 developers will be working individually in their own laptops, and they'll start working on very small fragment of this particular feature. And then later on, as they keep developing, they'll start pushing it to a version control repository, what we call it as GitHub. I hope you guys might have gone through the concept of GitHub, right? Once they start pushing their source code to GitHub, what happens? Once the code is pushed to GitHub, there needs to be some automatic systems in between, which means there needs to be some automated systems in between, which automatically does the entire workflow that you have just mentioned without your human intervention, which means the moment when a developer checks in their code to a version control system, let's name it as GitHub, right? What have you mentioned next? Immediately, there needs to be, what happens when you immediately push the source code? You would need to run unit tests. You need to run, basically you need to run unit tests. You need to run code coverage tests. You need to run some other, some other platform related tests. And then later on, finally, if everything looks good, which means after running unit tests, after running code coverage tests and so on, finally, you would actually use a build tool like Maven or Ant in order to create a build or artifact, right? And I mean, you need not worry about what I'm talking about right now, but these are the steps that you need to perform in this particular box, okay? Which is step 2. And then later on, once I create an artifact from this stage, then later on you would have to basically promote this artifact and push this artifact to the next stage. So who is performing this series of actions? And then later on, who is performing this action of pulling this artifact and deploying and again deploying here and again deploying here and finally shipping to production and finally shipping that app or product to the end client. This entire process is called as DevOps, which means you would be no longer or nowhere involved as a part of the entire SDLC platform, and you or your existence or your role will only come during the phase of pushing the source code to GitHub. And after that, entirely it's the DevOps principles or the DevOps processes or the DevOps tools that you pick will do the job from point A to point Z, and finally it will ship the code. So this is how you would have to understand DevOps as, and this is the kind of answer that an interviewer will be expecting from you.
Okay.
Make sense?
Yeah.
Cool. Awesome. So that is DevOps. You should have actually, you guys should have been in a position to explain what DevOps is, because that was already taught by the previous trainer. I'm not going to get into the previous classes once again, but I just wanted to give a recap of what DevOps is and why would we need DevOps before learning cloud. Okay. So in tomorrow's class, we'll straight away get into AWS console, and then we'll start learning AWS resources one after the other. So prerequisites for tomorrow's class would be is to everyone go ahead and create a free AWS account. All you need is just an email ID. You can just go to Google and then later on type AWS free account. It will help you create free AWS accounts. Just make sure you guys be ready by tomorrow. Point number 1. Point number 2 is once you create your free AWS accounts, I'll be sending you all a few links today about why everyone or why every client is moving to cloud, pros and cons of moving to cloud. And then later on, I might be asking you all a few questions on Linux and Python, because there is nothing much I can ask you all tomorrow in the class. Okay.
Okay.
Sounds good. Any other questions?
Hey, Sri.
Yep.
I just have a quick question. So you keep mentioning DevOps engineer and cloud engineer. Are they basically the same role?
Very good question. Okay. Yeah, that's a very good question. Most likely a DevOps engineer, you'll be hearing these different terms, okay? A DevOps engineer or a cloud engineer or a systems engineer or as an SRE, site reliability engineer, or a platform admin. You know, these terms are used interchangeably. I would not say they are 100% same, but they are similar, which means their roles and responsibilities overlap. A site reliability engineer is the one who is basically responsible to make sure systems are built and in place for different applications. But a guy or a girl who's hired as an SRE will also perform DevOps workloads. So typically in the job market, all these terms mean they are, I would say, 85% to 90% same, but not 100% same.
Srinivas,
When you're hired as a cloud engineer, you are 100% asked to focus on cloud related workloads, but it doesn't mean that you'll not be doing DevOps workloads, which means you'll still be working with Git, you'll still be working with Jenkins, Ansible, and all the other DevOps tools. But your main focus will be towards cloud and cloud migration. And when you're hired as a DevOps engineer, you'll be still doing DevOps workloads as well as cloud-based workloads. Make sense?
Yes, thanks.
Cool. Awesome. We'll call it a day. Happy Friday, everyone. We'll catch up tomorrow, and I'll let you all know the class timings for tomorrow well in advance, maybe by tonight. Okay?
Thank
bye.
you.
Thank you.
Thank you.
Thank you.
Have a good one.
Thank you.